Hello students, I am Dr. Ritapa Bhattacharjee. In Physics Department, I am working as Assistant Professor in SBIST. Let us today learn some formula and problems related to Compton wavelength. Now, for Compton wavelength, the concept is when an incident photon falls on an electron at rest, the electron makes the photon to scatter at a particular angle. And due to this collision of the photon and the electron also do not stay there. It recoils at a particular angle, say theta. So if this is the case of a collision of an stable electron and a photon, so what will happen? Both of them will have some different value of energy and momentum after the scattering. So, using this concept, Compton gave some formulations, and I will just directly take the formula of Compton wavelength, that is, after scattering, what will be the wavelength of the photon. So, like that, remember, this is the Compton wavelength formula, which is given by lambda c is equal to h by m0c, where h is your Planck's constant, m0 mass of the electron, and c is the velocity of light. So, from here, the Compton shift means before scattering the wavelength of the photon, and after scattering the wavelength of the photon will not remain same. So, if you are calculating the shift in the wavelength before and after collision, how much the wavelength shifted for the photon. So, the formula Compton gave as from Compton's for relations we get delta lambda is equal to lambda prime minus lambda, where lambda prime is the after shift wavelength of the photon and minus lambda is the is the wavelength of the photon before the scattering. So, this formula it will be equal to h by m0c into 1 minus cos phi, where phi is the angle at which the photon is scattered. So, this is the angle. So, now we will be doing some problem which came in MAKAUT previous years using these formulas. So first, before that, one more another three useful formulas I want to give, because the problem is based on this. So you have seen the Compton shift is given by this formula. And so in this angle, if you write phi equal to 0, the Compton shift will be equal to 0. Then since it will be equal to 1, so 1 minus 1 is equal to 0. So the value of the Compton shift will become 0 if the scattering angle of the photon is phi. So it means what? No scattering along the direction of incident photon. Okay. Now, if this angle is pi by 2, means 90 degree, so the Compton shift will be cos 90 equals to 0. So the value will be h by m0c is equal to lambda c. That means the Compton shift becomes equal to Compton wavelength when the scattering angle of the photon is 90 degree, okay, or normal, okay. Now, the third formula is when phi equal to pi, means 180 degree is the scattering angle. In that case, Compton shift will be, so cos 180 degree equals to minus 1, so 1 minus minus 1 is equal to 2, so 2 into h by m0c. this formula, this is the highest value of the shift of the Compton's wavelength. So it is written as when phi equal to pi, the Compton shift is the maximum. For maximum Compton shift, we need to have the scattering angle of the photon as 180 degree. Okay, so based on that, let us look at some problems which came in the year of MAKAUT 23-24 even semester. So it is a 1 mark question. So 1 mark question, it is it's just a 1 mark question. So it is given here, write the expression of Compton wavelength. Already you have seen the answer, although I have written it for you. In exam, always write the, you have to indicate which term is what. So lambda c is equal to h by m0c, where lambda c is the Compton wavelength, h is Planck's constant, m0 mass of the electron, c is velocity of light. So this is the answer of this question. Now next question is what? In the same year, the next question, this is also 1 mark. And the next question is, the Compton shift is maximum when the scattering angle is ... Means you have to do this, fill up the gaps with the answer. So the answer is what? Already you have learned. The Compton shift becomes maximum when the scattering angle is 180 degree or pi radian. Okay? So this is the answer. Next. Next I have taken a problem based on the, and that problem is also in the same year 2023-2024 even semester. So the marks allotted for this problem is 4 marks, and the question is, we will read the question by with all the terms here. X-rays of wavelength 1.2 Angstrom undergo Compton scattering due to electrons. So what is the questions given here? I will take a red pen and I will underline for you. So they have given X-rays. So whenever you see X-rays are there, so always remember Compton shift is possible with X-rays photon. Other wavelengths cannot show the Compton characteristics because of their wavelength range is not suitable for it. So whenever you know that X-rays are there, so X-rays of wavelength, so they given the data X-ray and they gave some wavelength of the X-ray. So incident wavelength of the X-ray is 1.2 Angstrom. They undergo Compton scattering due to electrons. So some X-rays went there, here some electrons were there and they got scattered and electron got recovered. So question is, what is the maximum possible value of Compton shift? So just underline this part, that what is the maximum possible value of Compton shift? Means they already gave you an indication that maximum possible wavelength shift has a particular formula, means scattering angle is 180 degree. Okay, so using you have to use that formula. So what is the maximum possible value of Compton shift if the Compton wavelength of electron is 0. So they have given you some data. Compton wavelength of electron is this. So marks allotted is 4. So this is the Compton wavelength. So let us just solve it very easily. You can do maximum possible Compton shift. This is the formula. Delta lambda is equal to 2 into h by m0c is equal to 2 into, so this value is what? H by m0c. This is nothing but the Compton wavelength. So I have written here delta lambda is equal to 2 into lambda c. Now in the question you already have the Compton wavelength value. So that value was in Angstrom. 1 Angstrom is equal to 10 to the power minus 10 meter. So I have written in the value into 10 to the power minus 10 and multiplied it with 2, and the answer of the question is 0.04852 into 10 to the power minus 10 meter. So that is the answer of it, very simple. I hope you understand. Thank you so much.